Hi, I'm Sonia. I'll be introducing our work, Language-Aligned Waypoint or Law Supervision for Vision and Language Navigation in Continuous Environments. In the Vision and Language Navigation task, an agent is given navigation instructions in natural language and it needs to follow the instructions to navigate through the house. In the most common formulation of the task, a discrete environment is used where the agent can only move to discrete locations. We focus on the continuous environment setting, also known as VLN-CE, where the agent can move around more freely. The agent is trained with ground truth actions from the start to the goal. In the initial VLN-CE work by Kranz et al., the agent is trained using a goal-oriented supervision. At each step of the navigation, it is supervised with actions based on the shortest path from the agent's location to the goal. However, the shortest path to the goal is not always the same as the path corresponding to the instruction. In this work, we propose to supervise the agent with actions that take the agent towards the language-aligned path. This path is characterized by intermediate points called waypoints. The waypoints align to parts of instruction in the dataset. At each step during training, the goal-oriented supervision from prior work is an action that takes the agent towards the goal irrespective of the instruction. In contrast, our language-aligned supervision encourages the agent to move towards the nearest waypoint on the language-aligned path. This brings the agent back on the path if and when it deviates. Our agent adapts the cross-modal attention or CMA model from previous work. The model receives RGBD image and language instruction at each time step and predicts an action. During training, we use cross-entropy loss to maximize the log likelihood of the ground truth action A* at each time step. We train the agent by supervising it with action from the agent location to the nearest waypoint instead of the goal. Note that we can vary the granularity of the waypoints along the language-aligned path. The waypoints can be fine-grained, corresponding to the agent's step size, or more spaced apart, corresponding to positions of panoramas at discrete locations. We find that using panoramic waypoints works the best, and we call this model Law Pano. We compare the performance to the baseline model, which uses the same architecture but is supervised using a goal-oriented path. We measure the model performance using standard VLN metrics. Success rate and SPL measure whether the agent is able to reach the goal. However, we focus on the metrics that capture how well the agent is able to follow an instruction. Normalized dynamic time warping or NDTW evaluates how well the agent trajectory matches the ground truth trajectory as a whole. Success weighted by normalized dynamic time warping or SDTW combines NDTW with the success rate, considering only successful episodes. In addition, we introduce a simple intuitive metric called waypoint accuracy that measures the fraction of waypoints the agent is able to visit correctly. We find that our Law Pano model performs better than the baseline across all metrics in both seen and unseen environments. This suggests that language-aligned supervision encourages the agent to follow instructions better than the goal-oriented supervision. We visualize the agent trajectories on an unseen episode for both the models. We find that the path taken by the Law Pano agent conforms more closely to the instructions. In conclusion, we find that the language-aligned waypoint supervision or law is a simple but useful strategy for the instruction-following nature of the VLN task. This supervision method can be easily plugged into any model architecture. We also find that the waypoint accuracy metric helps us with analyzing agent trajectories. Thank you for listening. To find out more on dataset analysis and additional experiments, please check out our paper and webpage.